Calculate delays. It's computer sciences network. So what I've already done here is I've written the distances between each and every node. 9 kilo, here it is. This is what I've just written. N1 to N2, it's 9 kilometers. N2 to N3, it's 18 kilometers, and so on, right? So now the first question says, determine the approximate transmission rate when communicating between N1 and N7. What they're actually asking for here, it's the speed at which the packets or the data actually moves from N1, N2, N3, N6, N7, right? So that's what they're actually asking us to determine. And the transmission rate is usually controlled or determined by the bottleneck. Remember, the bottleneck, it is the slowest or the smallest transmission or the smallest transmission speed between nodes. For example, here we are, it's not actually for example, we're answering the question from N1 to N7, right? We start from node 1 to node 2, it's actually what, 77 megabits, and then from N2 to N3 it's what, 21 megabits. Now we compare between the two, which one is the smallest. It's 21 megabits per second, so which means so far we are holding 21 megabits per second as our bottleneck. Then from N3 to N4, it's 70 megabits per second. Compare it to the previous one that we are holding, which is 21 megabits per second. 21 megabits per second remains the smallest. Then from N4 to N6, it's 17 megabits per second. Compare it to the one that we are currently holding, which is 21. Therefore, we replace it with what? 70 megabits per second, because that's the smallest. That is our current bottleneck. Then from N6 to N7 is 27 megabits per second, and it's higher than 17 megabits per second. So our transmission rate in this case, is transmission rate. It's equal to what? To the bottleneck. And our bottleneck is what? 17 megabits per second. Now we've answered question number 1. Then let's go to question number, here was question number 1. It's question number A actually. Now let's go to question. I had to pause a little bit there so that I can get the questions. Okay, now the question says what? Taking this approximate transmission rate, remember the transmission rate that we got was what? Was 17 Mbps. Into account, how long in seconds will it take to transfer a 15 megabit file from node 1 to node 7, right? So now they're actually asking us its time. The moment they say how long, they're actually asking for what? For time. Okay, now let's go to time. Time is referred as what? Transmission delay. So the question is asking for what we call transmission delay. Okay, let's calculate our transmission delay. Question number B, right? Transmission delay, it is equal to what? The packet size, usually can even call it data size. It is divided by what? The transmission rate. Okay, those who did physics, this is more similar to what we had in physics, right? Whereby we know that dst, which if you want to get what? If you want to get the time which is our delay, it's going to be what? It's going to be distance over what? Over speed. Distance over speed if you want time. But if you want what? If you want If you want the distance itself, it's going to be what? Time multiplied by speed, right? But if you want if you want speed, is going to be distance over time, right? Yeah, that's it. We know that. Okay, so let's continue with our question. Transmission delay is equal to data size over time. But one thing that we need to know when it comes to the data or the packet size, it's always that whenever we are dealing with these calculations, wherever you see mega, we need to convert it to what? From megabyte, we need to convert it into megabits, right? For example, you need to know that each and every 1 byte, it is equal to what? 8 bits. And we need to convert what? This 15 megabyte to what? To megabits, right? So in order for you to convert this is just going to be cross multiplication, right? We've got how many here? We've got 15 megabyte, so it's 15 here, what? And then this is the x that we're actually looking for, right? So it's going to be cross multiplication. It's going to be, so wait, give me a minute. I just want to see if we have, okay, we've got 15. It's going to be cross multiplication, whereby our x, it's going to be 15 times 8, and 15 times 8 is 120, right? So now this is what? 120 bits. But remember, it was 50 megabytes, so it's going to be 120 megabits. So always, whenever we're dealing with packet size or data, whenever we're dealing with the transmission delay, if ever we're given an MB, we need to change it to what? To this. We need to change it to this, right? And this is what we did here in our case. We need to change it to a megabit, from megabyte to megabits. So which means here we're going to have what? 120. And then the transmission rate. Remember, the transmission rate is our bottleneck that we got from the previous question, right? And it was what? It was 17. So in our case now, we're going to have 17. We're going to have 120 divided by 17, which should be equal to 7.059. I'm just rounding out off to 3 decimal places, but the question would have said somewhere here, are we rounding off to what? To 2 decimal places. Nah, at this point I'm just mising the question, but it's fine. So we've got what? This is 7.059 seconds, right? And this is the time, or the transmission delay. We've answered question number B, right? Now we go to question number C. Question number C says, if it is determined that the medium installed in this network propagates a signal. Remember, propagation, it's when that the packet, when it has entered through the link, say this is router A, and then this is router B, and then the packet has entered, it's on moving on this link, right? So propagation refers to the effort to push this packet from A to B. That's what we refer as propagation. It says this network propagates a signal at a speed of 100 kilometers per second. Calculate the propagation delay. Propagation delay will be referring to what? Time. Okay, we need to calculate the time for communications between N1 to N7. What? Let me see. N1 to N7, right? So we're still working with the same nodes, N1 to N7. So whenever we're calculating propagation delay, remember, nothing much really changes. In our case here, they didn't specify stuff like what? They didn't specify stuff like node what. There's a lot of delays that actually take place when it comes to moving packets, right? There's node nodal processing delays and so on and so on. So we are dealing with propagation delay now. When it comes to propagation delay, what you need to keep in your mind, it is the total distance. You need to know the total distance, because since propagation delay, it's explaining the effort taken. Propagation explains the effort taken to move the packets from all these points until N7. So we need the distances across here. So we're going to have total distance for total distance. We're going to have what? 9 and from N1 to N2. So let's call that distance 1, whereby we know that it's N1 to N2. I'll just be writing underneath as well here. At how many? It's 9 kilometers, right? 9 kilometers plus we need what? We need N2 to N3, which is 18 kilometers. So 18 kilometers, which is distance number 2, N2 to N3. And then the third distance is from N3 to N4, which is 103 kilometers. 103 kilometers. Distance number 3 is N3 to N4. And then distance number 5, it's N4 to N6. This D4, N4, N6. So obviously D5 is going to be what? N6, N7. Right. And then this one was 63 kilometers. The other one is what? 3 kilometers. 3 kilometers. And then the total is 196 kilometers, right? And this is what we have. Hopefully I'm calculating these distances correctly. I hope so. Okay, then now we need to go to the what? Answering the actual question, right? We need to answer the actual question. Now the actual question is propagation delay, right? Yeah, let me confirm. Okay, I was asking you propagation delay. So what is the formula? Propagation delay, nothing changes. The similar equation. Remember when I showed you with this stuff here, when I said speed is going to be distance over time, right? Speed is distance multiplied by time or distance over time. Speed is distance over time. Yes, I'm correct. Distance over time. So in our case, we're going to have propagation delay. Propagation it is equal to distance and then speed. And then speed, propagation speed. They gave us the propagation speed, remember? Okay, in our case, the distance is what? 196 kilometer. And then the speed was what? 10,000 what kilometers per second. So this we know for sure. If we punch on our calculator, it's going to give us 0.0196. I'm just converting to I'm rounding off to the nearest 4. And then you know these are going to cancel each other, so we're left with seconds, right? So you can either convert this to millisecond if you feel like you want. Converting this to millisecond, you'd have to multiply with 1000. It's going to give you 19.6 millisecond. But it's not important to do this. This is the most safe way, because if you want to use this value, most likely you're going to use it as what? As centimeters. Now let's move to this last question. The last question says that assuming that there's no nodal delay, which means this is 0. and then there's no queuing delay. This is 0 again. What will be the total time taken to transfer a 20 megabit? We have an issue. We need to change this. It's a megabit, right, file from N1 to N5. You can assume that the network also propagates at what? At 10,000 kilometers per second. Good. Now we're moving from what? N1 to N5. Come here. We're no longer coming this side. This one it's out now. We are moving from here, 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 and here. This is where we end. So this will be our starting point, and then this will be our finishing point. Right? Assuming that you are also doing informatics, you know that this means start, that means ending point. Cool. Alright. Let's answer the question right now. The first thing that we need to do is let's understand the formula for calculating all this. The formula is the delays in total. Let's calculate number what? It's number C, right? The total delays of a packet moving from A to B, or from wherever A, B, C to wherever they are going, it's always going to be what? It's always going to be the propagation delay. Let me just write D and then say proper. It's always going to be the propagation delay plus what? Plus the transmission delay plus what? The nodal delay. These delays, they've said we need to assume that they are not even existing in our case. Nodal delay and the queuing delay plus D nodal plus D queuing delay and so on, right? So already we know that these are 0, so we're just going to, we need to determine what? Propagation and transmission delay. Remember, our transmission delay usually it's determined by what? The bottleneck. And remember, now we are moving from what? From N1 to what? To N5, which means we need to re-establish our calculations for the bottleneck. We go back. Then from N1 to N2, we've got 77 megabits per second. N2 to N3, we've got 21 megabits per second. N3 to N4, we've got what? 70 megabits per second. N5 to N4 to N, then N4 to N5, we've got 28 megabits per second. This is no longer our case because we're no longer moving this route. So between this 1, 2, 3, 4, we need to determine the smallest, right? In our case, it's what? 21 megabits per second. That becomes our new what? Bottleneck. So the bottleneck is what? Bottleneck. Remember, transmission rate equal to bottleneck. In our case, then this equals to what? Equals to bottleneck. And then in our case, this equals to what? 21 megabits per second. Cool. We have what? We have our transmission rate. This is our transmission rate. We need to convert it to what? Delay, because we are actually calculating for delays, right? So to remember transmission delay, I'll just go and copy this formula because I've explained it before. So here it is, transmission delay, copy, saving time. You know, you can actually get a tablet to save time. Just jokes. Okay, transmission delay is equal to what? It's going to be transmission delay per data packet size. Remember they said what is the new packet size here? 20 megabits file, right? So we need to convert this 20 megabyte to megabits. So we are going to have what? Let me just write it on the equation, but you can do it separately, right? You now understand the procedure. 20 times 8 over what? Transmission rate 21. Now this is supposed to give me 7.619 seconds. Just rounded off to 2-3 decimal places. Okay, now let's move to what? Let's move to we actually got this now. We got this. We need to get this now. Remember, the propagation delay needs us to know the total distance in our case. Ne? So the total distance, and remember, it's from what? N1 to N5. In our case, I'll just quickly do this, calculate it quick. We have 9 kilometers plus 8. We have got, let me see. We've gotten, oh yeah, sure. 9 kilometers plus 18 kilometers, which is equal to 27. Then 27 plus, it's equal to 130. 130 plus what we going to 33. It's going to be 163. Yeah, because now we're not moving down this road, remember. We are moving up. So it's 9, 18, 103 and 33, right? Because it ends here. So now we're going to have 163 kilometers in total. So we've got 163 kilometers in total, right? That's the total distance. And then to calculate the propagation delay, for now, let me just call it PD. You already know the equation. Here it is, here it is, here it is, here it is, here. So it's equal to PD, it's equal to what? TD over what? Over P speed, right? And we know that the distance is 163 kilometers divided by 10,000 kilometers per second, right? In our case, this is going to be what? It's going to be 0.0163 seconds, right? Good. We need to use the same units. Remember, this is our what? Transmission delay, and this is our propagation delay. Then the total delays are going to be what? Our total delays are going to be 7.619 seconds plus plus 0.163, and then what? Multiplied by sec. I mean, you could have just written sec here, but nah, I just decided to do it like that. My preference is going to be 7.6353 sec. If you're actually listening to the instruction, they say we should round off to the nearest 2, right? I was gonna write something like 64 sec here. So yeah, that's how you actually calculate these things, eh? Yep.